Okay, so we've got one more detail to discuss about section 2.7, and that's the idea of symmetry, the concept of symmetry. We studied three types of symmetry in our class: the x-axis symmetry, y-axis symmetry, and the origin symmetry. If you know what the graph looks like, oftentimes you can kind of just determine it by visual, by just folding your paper and looking at it, and we'll talk about that. Then sometimes as a graph we don't know what it looks like and we have to check it algebraically, so we'll discuss both of those. So first, let me show you some examples of our basic graphs and what their symmetries are. So for the y-axis, and I'm going to talk about the x-axis last, but for the y-axis, an example would be y equals x squared. If we look at y equals the x squared graph, that's our parabola shape. If you fold it along the y-axis, the two curves meet. That's it when it's in its basic form. You can shift it up and down and it still has its symmetry actually for the y-axis. If we move it left, right, it's going to lose its y-axis symmetry. It's still a symmetric figure, but it won't be symmetric with the y-axis any longer if you scoot it over. Right now, as long as it's centered at the origin or even moved up or down, it still has symmetrically, it will fold along the y-axis. So that's one. Another example of y-axis symmetry is our absolute value function. If you fold that along the y-axis, again, as long as it's in its standard form or even shifted up or down, it still has its y-axis symmetry. And then another example, which this is not one that we use as much, but x to the fourth is just a little, it looks a lot like the parabola. It's not officially in a parabola, it has a little bit of a wider base, but it's another example of a symmetric with the y-axis. So you might notice in this, as long as all of the exponents are even, x squared, absolute value of x sort of counts in that idea because you're getting the same output for y, whatever x is. Y to the fourth, if you have all even exponents or it's in absolute value sign, you're going to have y-axis symmetry. And we'll talk about how to check that more officially algebraically in a minute, but just looking at it for right now is what I wanted you to see. Y-axis means you can fold it along the y-axis and it meets. All right, the third one down here, the origin symmetry. Origin is actually rotation, a rotation symmetry, rotation of 180 degrees. If you can take the graph and sort of spin it halfway around a circle, 180 degrees, spin it through two quadrants, and it looks the same, it lies back on top of itself, that's origin symmetry. So looking